Welcome to this presentation on the NX Human Modelling module. NX Human Modelling enables designers to use 3D human models to explore and verify how people of different sizes will interact with their product designs. It is based on Siemens industry-leading Technomatics JAX software. NX Human allows rapid evaluation of fit, clearance and reach issues without leaving the design environment. With human modelling integrated into the NX product design tools, companies can develop safer, more functional products that have greater user satisfaction. Integrated human models can be placed in the design early, allowing you to optimise your product designs for ease of use. Use human models to gain better understanding of proportion within your 3D CAD environment. The NX Human toolbar has 4 icons. Human, which will place a new human model within the file. Reach Zone helps you generate surfaces that depict areas of maximum reach for digital humans. And Comfort Assessment provides dynamic feedback on how comfortable the human is in a particular posture. The Predict Posture command positions a human model driver, front passenger or rear passenger, in a seated position inside of an automotive vehicle. You can position the hands and feet in a specific location. For example, you can place the driver's hands touching the steering wheel and have his feet touching the brake pedal. Upon inserting a human, you can create a new human or import a human from an existing library. Each human will require a name. In this case, I'll call him Jack. 2 stature databases are supplied: the Army Anthropometric Survey and the National Health and Nutrition Examination Survey. Statistical data from these surveys encompasses over 75,000 individuals. The gender and stature of the human can be selected. The reference point of the model will select what point on the model will be used to place it within the 3D environment. Once the model is placed, selecting the model will open the Edit Human dialog. Edit Human display adds coordinate systems at specific locations on the model used for positioning or measurement. Modify Human adjusts the input parameters used to create the model. Here I'm adjusting the weight to 105 kilograms and the model's proportions update. At any time, the joints can be manipulated by using the coordinate system associated with the joint. Each joint in the hand can be repositioned to define a grasp, and hand shapes can be stored in a separate hand library. The segment scaling dialog box lets you change the selected segment's scale factor parameters. Advanced Scaling dialog lets you change a segment scale factor by entering values such as length, height or depth in an input box. The posture library can save or recall postures. The library supplied has a selection of postures. Examples: carry load, kneel 1 knee, kneel 2 knees, running, seated and shoveling. The hand shape library can recall or save hand gestures. A hand shape library is supplied with the software. Use inverse kinematics to move the limbs on the human model to the position you want without adjusting each joint. You can use the command to move the head while the eyes are fixed relative to the head, or have the eyes follow a moving point while the head remains fixed. Dynamically drag the manipulation handle to move your selected body object to the location you want. As you drag, the human model moves dynamically and the software calculates the human posture based on your drag motion. The manipulation of hands requires additional information, but you can manipulate the other body objects by providing only the manipulation handle information. With Active Reach, you can generate the human posture by defining the goal location of the hands. If you want the human model to reach out to something that is out of reach, specify the hand position for the human model by using the hand figures. You can also apply hand shapes to give the required shape to the hands. Inverse kinematics then calculates the best location and posture for the human model based on your specifications. Reach Zone helps you generate surfaces that depict the areas of maximum reach for digital humans. First, I will modify the left hand to point. Select the reach zone, pick the left finger and calculate. The zone appears as a translucent surface. Comfort assessment helps you determine whether you've positioned a human model in a comfortable posture. Comfort assessment is a two-step process that involves comfort setup and comfort analysis. Comfort setup involves selecting the human model, then selecting the study name. Here I will use Dreyfus 3D. Selecting comfort analysis displays the comfort analysis result. The icons on the left of the chart indicate different joint angles. The green band denotes the comfort range for a particular joint. A joint parameter shown in green indicates the particular joint is within the comfort range. The red band denotes the discomfort range for that joint. A joint parameter shown in red indicates that the joint is uncomfortable in that posture. When editing the joints of a model, the comfort assessment is performed dynamically as the joints are moved. Use the Predict Posture command to position a human model driver, front passenger or rear passenger in a seated position inside of an automotive vehicle. You can position the hands and feet in a specific location. For example, you can place the driver's hands touching the steering wheel and have his feet touching the brake pedal. The Predict Posture command requires a number of inputs. The vehicle type in this case is Class B, which is a commercial vehicle. Car coordinate system sets up the vehicle origin and orientation. The seating reference point defines the hip point of the model. Accelerator heel point defines the location for the right foot. Select the human for the study. The steering wheel is selected next as a solid body. Then the solid body that represents, in this case, a footrest. The right foot location is taken from SAE data. A preview is then calculated. The foot location is modified down 30 degrees and then recalculated. A preview of the left foot location is calculated next. The hand locations on the steering wheel is now calculated. Within the Predict Posture command, the hand shapes and locations can be modified. The model of the driver is now seated. NX Human Modelling software allows the user to do ergonomic analysis within the NX CAD design environment. Additional human simulation tools are available from Phoenix PLM. Jack and Process Simulate Human enable you to improve the safety, efficiency and comfort of your workplace environment using digital human models. Technomatics Jack is a human modelling and simulation tool that enables you to improve the ergonomics of your product designs and to refine industrial tasks. Jack and its optional toolkits provides human-centered design tools for performing ergonomic analysis of virtual products and virtual work environments. Jack enables you to size your human models to match worker populations, as well as test your designs for multiple factors, including injury risk, user comfort, reachability, line of sight, energy expenditure, fatigue limits, and other important human parameters. Using Jack facilitates significant cost and time savings by enabling you to improve product quality and process feasibility early in the product lifecycle. Technomatic Software's Process Simulate is the digital manufacturing simulation tool for developing and verifying process plans for your plant's manufacturing systems. Process Simulate Human is an add-on application that extends this functionality by enabling you to realistically simulate human tasks, access human performance, and create effective ergonomic studies. You can use Process Simulate Human to optimize the layout of your plant's work areas and validate the feasibility of manual assembly.